hope I didn't lose the first video that I made. All right, for number 2, continuous function f is found in the closed interval from -6 to 5 inclusive. The figure above shows a portion of f. The graph of f consisting of 2 line segments at a quarter circle centered at the point 5, 3. It is known that the point 3, 3 minus root 5 is on the graph of f. And we're trying to, in part A, it says if the definite integral from -6 to 5 of f of x dx is equal to 7, find the value of the definite integral from -6 to -2 of f of x dx and show the work that leads to your answer. So they're not giving you the whole picture here. They're just telling you, well, before, if you include it, everything from -6 to 5, you get 7 as the net signed area. And now we want to figure out what's the area of, or the net signed area of the stuff we can't see from -6 to -2. All right, so let's go do this. This is mostly a geometry problem. And so let me see if I can put some things down here. So -6 to 5, f of t dt, this is equal to 7. And then what we should know is that the integral from -6 to -5 of f of t dt can be broken down into the integral from -6 to -2 of f of t dt plus the integral from -2 to 5 of f of t dt. Now that's important because that's going to first demonstrate our initial understanding of the calculus that has to happen. There's one point for just doing that, okay, for correctly breaking this integral down into 2 smaller integrals that we're going to find the value of. Obviously over here this is 7. This is what we're looking for. You can call that A. So all I need to do is find the area from -2 to 5 and then subtract it from 7 and I'll get the answer. Now going back up here to the picture from -2 to 5, we just got to correctly find the areas. Now in here, because we have a slope of 1 and this triangle here is above the axis with an area of a half, and this is below with the area of a half, those are going to cancel. Positive and a negative, exact same value. Those are going to cancel. And then what's actually going to happen here is we're going to have the same thing, okay? This is a slope of 2. This is at 1/2. This is 1/2. This is -1. This is 1/2. This is +1. This area here is going to cancel with this area over here, okay? All of that goes to 0. So all we have to worry about on this is the area around this region here. And I just totally messed it up. So let me get rid of that if it'll allow me to. All right, but that's the region we got to find next, okay? And this is, you can think of it a couple different ways. You can think of this as a trapezoid. We got base 1 and a base 3 and a height of 1. And so that's going to be, I said, base 1, base 3, height of 1 divided by 2, and then plus whatever happens in that next region here. Now this you should do a little subtraction for. If I took the area of this entire region here and subtract from it the area that's the quarter circle, I'm left with the area that we want. The whole thing is just a square of side length 3, so it has an area of 9. The quarter circle has a radius of 3, so it's going to be, area of a circle pi r squared divided by 4, and I'm going to subtract that from here because I'm getting rid of the quarter circle. So it's going to be 9 pi 3 squared pi r squared, so 3 squared, then divided by 4 because we only have a fourth of that circle. And then if we solve for a, it's just going to be 7 minus, let's see, 3 plus 1 is 4, times 1 is still 4, divided by 2, that's 2. So minus 2 minus 9 pi over 4. That's what the area of A is. I already got that on the other side. If you want to simplify that you know, you can. And what do we get? 7 minus 5, 7 minus 2 is 5, minus 9 is going to be negative 4, and then distribute the negative here. We're going to end up with 9 pi over 4 minus 4. Don't reach for a calculator for this, ladies and gentlemen. Do this without a calculator. Some of you reach for a calculator, didn't have a lot of work, and I can't give you credit for that. They're not going to give you credit for that on the AP exam. So don't do that. All right. So for part B, we're going to have to evaluate this definite integral from 3 to 5 of 2 times f prime of x plus 4 with respect to x. A lot of you made a silly mistake and thought the antiderivative of f or 2f prime was going to be f squared. No, that's just not true, unfortunately. If you want to break this down into parts here, you can go the integral from 3 to 5 of 2f prime of x with respect to x plus integral from 3 to 5 4 dx if you want. You can even further bring the 2 outside if this helps you see things a little bit more clearly. Over here, well, I'll just leave it alone for now. There's a couple different ways. You can interpret it as area and just do it as a rectangle, or you can do the antiderivative. But the antiderivative of f prime is just f. So this is just f of x from 3 to 5 here. And then plus, like I said, this is a rectangle with a base of 2 and a height of 4. So, or you could just do 4x from 5 to 3. It doesn't really matter. So this becomes 2 times f of 5 minus f of 3, and then plus 8. And then we got to go back up to the picture. F of 5 is 0, and f of 3 is, didn't they tell us that? F of 3 is 3 minus root 5. So this is 2 times 0 minus 3 minus root 5 plus 8. And then if you work that out, if you distribute the 2 and the minus, you get a negative 6 plus 2 root 5 plus 8, or just 2 plus 2 root 5. You don't need to do all that. You could stop here. That's correct. And why bother to make a mistake accidentally because you're going fast and you're thinking about so many other bigger concepts? Don't bother. Stop. All right, for letter C, they give this function g. It's an integral from negative 2 to x, f of t dt. We want to find the absolute maximum value of g on this interval, negative 2, 5, and we want to justify our answer. Just add this to here. So it's a closed interval, absolute maximum. Did I see maximum? Yes, maximum. So closed interval methods, find the largest output using the usual methods. Every time they define a function as an integral and they have you do something where you're taking the derivative, they're giving you a point for the fundamental theorem for just pointing out that when you take the derivative of g, you get f by the fundamental theorem here. Okay, it's an easy point to get, but some of you aren't getting it because you're doing it mentally and not writing it down. And if you don't write it down, they don't know you know it, and they're not going to assume that you do. You're not going to get the credit. We did know an f is equal to 0. Let's go back up to the picture. Negative 1, 0.5, and 5. Negative 1, 0.5, and 5. 5 is an endpoint. Okay, they give you another point for identifying the zeros correctly that you need to use. So we need g of negative 2. We're going to need g of negative 1. We're going to need g of 0.5 and g of 5, which we already calculated. This was going way back up. Did we already calculate it? Yeah, it should. Yeah, it's all this stuff way up here. So we have that. That's whatever that happens to equal, and I'll deal with that in just a moment because right now my brain is not working very well. This is from -2 to -2 f of t dt, which is just 0. Now g of -1 is the integral from -1. I'm sorry, from -2 to -1 f of t dt. And so it's the area or net signed area from -2 to -1. I'm sorry, to -1. So we already saw that that's this area right here, which is just half. And g of 0.5, so this is the integral from -2 to 0.5 f of t dt. And from -2 to 0.5, okay, so we have positive half minus half, which is 0, and then we're going to have a fourth right here, right? So that's a half times 1, which is a half divided by 2, which is a fourth, but it's negative, so -1/4 right there. And then for g of 5, that's from -2 to 5, which is all that stuff that we calculated here. I know why I'm looking at the next line, and it doesn't make sense to me at the moment. So this is going to be 2 plus 9 minus 9 pi over 4. So I was looking at this mess here, and it didn't look right to me. So it's 11 minus 9 pi over 4. Integral from -2 to 5 f of t dt, 11 minus 9 pi over 4. And so we just got to identify the largest. Well, that's 0. That's a half. That's the only positive number. That's negative. Go throw that one out. 9 pi. Okay, well, let's just think this through for a moment. That's pi is a little bigger than 3, and so 9 times 3 is 27. 27 divided by 4, that's almost 7. It's going to be a little more than 27. 28 divided by 4 is 7, so it's not quite 7. So 11 minus something bigger than 7. This is still greater than a half. This is, just with confidence say this is greater than 1. So this is the max. And actually, you don't even have to justify it that much. Just say the max is g of 5. Actually, let me see something. They asked for the max or the... Yeah, so they want the output. So the max is g of 5 equals 11 minus 9 pi over 4. And use the closed interval method to demonstrate that one. And lastly, we got to find this limit. Now, I said recently that if you see a limit on the fear response question of the AP exam, you're probably doing L'Hopital's rule. I found a problem that proved me wrong. So no, this is not a L'Hopital's rule problem. If you actually just do direct substitution here, you're going to end up with 10 minus 10 to the first power minus 3 times f prime of 1 over f of 1 minus the arctangent of 1. You don't even have to know what the arctangent of 1 is. Now, you can't leave it like this. This is a one-point question. You have to figure out what f prime of 1 is and what f of 1 is. But you don't have to figure out what arctangent of 1 is if you don't remember that it's pi over 4. Okay? So this is going to be 10 minus f prime of 1. That's the slope of the graph of f at 1. Well, here's 1. What's the slope right here? Well, it goes up 2 over 1. Oh, it's got a slope of 2. 2 over 1. So going back down over here, this is going to be 3 times 2. And then f of 1, I should have looked when I was up there, but I didn't. F of 1 is 1. And so this is going to be 1 minus pi over 4, and you could stop right there, or you can just do the little bit of arithmetic and do that. You don't have to go any further. Some of you did correctly. So there it is, ladies and gentlemen. There are so many points that some of you are leaving on the table because you're not thinking through things carefully, or you're being a little bit sloppy or careless. Think through the concepts. You guys can get this. I know you can. So let's go a little more carefully. Let's apply what we know, and let's get the points that we deserve. Go study.